Hey guys, so in this video we'll just briefly talk about DBMSs and the relational model. So first of all, um, DBMSs are based on data models. Now these data models, they're different ways of representing data and describing that data and constraining and operating upon that data. Let's maybe write that down. Um, okay, so these data models describe data, and specifically they talk about the structure of the data, the constraints upon that data, and also some of the operations we can perform on that data. Um, and yeah, that's what these data models are all about. And you may have heard of different kinds of data models. We have the relational model, we have structured, semi-structured, um, graph data models. So there are different kinds out there. The ones we'll look at over the course of our videos is specifically the relational model, and we'll talk about it in just a bit. But it's important to note that there are different data models that exist, and they do uh, some of these things very differently. Okay, so now that we've talked about just what these data models are all about, let's actually talk about the relational model specifically. So the relational model. So we'll talk about the relational model, and note that there are other models, and some of the things we may talk about for the relational model don't usually or wouldn't directly apply to other models. So anyway, specifically for relational models, these relational models, they revolve around this concept of relations. So we have a concept of relations. Um, and we'll talk about relations later on, but that's the fundamental concept behind the relational model. And based on relations in mathematics, we can actually describe these relations. It's the same way you may have learned about relations in math, and we do algebra, relational algebra, and we have tuples and sets of tuples, and all these kinds of things that are based very heavily in mathematics. They're grounded in mathematics, the foundations at least. And then later on, we'll talk about specifics of the DBMS we'll look at, PostgreSQL, which makes adjustments and bends the rules a little bit. But for now, we'll talk about the traditional way the relational model does things. Okay, so you can think of relations as rows and columns, rows and columns, and you may have heard of uh, people talking about tables and SQL tables and things like that, and that's exactly rows and columns. Those are the rows and columns we're talking about. So yeah, that's pretty pretty basic and pretty easy to understand. We'll see later on when it comes to querying and things like that, um, how even this very simple model can turn into a pretty complex beast later on. But first, let's do a simple example of rows and columns so you guys get what I'm talking about. Okay, so let's run through a small example, and we'll have two tables, one called teams and another called games. And let's draw these out. This is the teams table. This is the games table. Let's need some space to write the name of the columns. This teams table will have 3 columns, and here in games we'll have 4. Okay, so first of all, we'll need team names. We'll need home field or home stadium. We'll need a manager for the team. And of course, we'll need some examples of teams within this table. So, okay, so let's write some random data here. Let's fill it up with first name will be Man U for this first team. Old Trafford will be the name of the stadium. The manager, let's just call him OGS because I don't know how to pronounce his name. The name of the next team will be Liverpool. I guess that's a little hard to read. Liverpool. Oh, maybe this just isn't enough space to read it properly. Okay, no worries. Anfield is the name of their stadium, and their manager's last name is Klopp. And Arsenal, their stadium is Emirates, and the last name of their manager is Emery. So we have these 3 teams, and we have the games that they've played. So here in games, we'll define what these columns are. So let's say first column, we'll call that the name of the home team that played. Let's say this is the away team that played. Let's say this is the home goals, or in other words, the number of goals that the home team scored. And of course, we have also away goals. And let's just keep it simple with 2 games. Let's say there were 2 games that were played so far between the first one between Man U, Manchester United, and Arsenal. And Manchester United scored 3 goals against Arsenal. In the second game, let's say Liverpool played against Manchester United, and they only scored 2 goals against the 4 that Manchester United scored. Now, this is a simple example, but it illustrates the kind of structure of data that we put into this table using the relational model based on the concept of relational databases. Okay, so we have rows and columns. That's the simple idea here. Now, let's talk about something else. Okay, now one thing to note is that relational model is very strict. The relational model is very strict. Okay, so we need to define a schema. A schema for our data. And that schema is basically the law of the land. That schema must be adhered to and must be followed. So all the rules in the schema must be followed. So yeah, that's basically it. Schema must be adhered to. Right? So schema must be adhered to, and now the model expects to have all rows to have data for each column, right? So model expects to have all rows to contain all data for each column, right? So basically, we need to have data in each entry of the table is what this is trying to say. Um, yeah, pretty straightforward. Um, okay, so let's talk about DBMSs again. So a DBMS will provide the following, right? It'll provide the ability to specify the logical structure of the data, of course, explicitly, um, and also have it enforced. Oops. And have it enforced. Yeah. Okay, so that's that's the first key point. It gives us the ability to specify a structure of the data, and we talked about schemas and different things and how the relational model is, or in the case of the relational model, the way we specify data in that schema is very strict. But in general, different DBMSs have different ways of doing things, and that's just the case for the relational model. So anyway, um, it also gives us ability to query or modify the data. Also um, gives us good performance, good performance under heavy workloads. Um, yeah, so there's a lot that goes into making these DBMSs, and that's why they just crunch through big data and a lot of queries really, really well. I'm just going to clear the space here. And one other thing that it guarantees is durability of data, right? Um, so let's say we have a bank transaction. We're on our laptop. That's a bad laptop. Let's say we're on a website, www.yourbank.com, and then we enter some info. Um, let's say we we want to e-transfer some money to somebody, and we e-transfer the money, to some other, banking institution or something else that receives that money. But all of a sudden, this banking institution, it has a power outage, right? It's out of power, and they cannot receive that money, but it got deducted from our account. So we see negative transaction here that let's say $100 was deposited to this other banking institution, which never even received that money because of the power outage. What happened? Did we just lose that $100 and it just went nowhere? Um, well, no, because the durability of data uh, of is guaranteed. So yeah, the durability of the data is guaranteed. And so we can rest assured knowing that we didn't lose our money or anything like that because of this property. So one other thing that DBMSs do well is give concurrent access to whoever needs it, whether that's a process, so to processes, or to users. Um, and there's a lot, again, that goes into DBMSs behind the scenes, right? There's different data structures, like B trees and whatnot, and depends even on which DBMS we're talking about, because each of them are implemented very cleverly to suit their own needs. Um, but yeah, there is a lot that goes into making these DBMSs, and that's why they work so well and crunch a lot of data and query a lot of data at very, very impressive speeds. So in later videos, we'll look at how we can use DBMSs to serve our needs.